हेलो बच्चों, तो हम लोग आपका टॉपिक कंटिन्यू करेंगे जो कि मैंने लास्ट क्लास कल स्टार्ट किया था, एटम्स एंड मॉलिक्यूल्स। तो सेकंड पार्ट विल बी योर रिगार्डिंग द लाइक आज हम पढ़ेंगे साइज ऑफ एटम्स, नेमिंग ऑफ एटम्स, वो सब के बारे में। ठीक है, तो चलिए स्टार्ट करते हैं। ठीक है, तो एटम्स पार्ट 2, लेट्स कंटिन्यू। एटम्स एंड मॉलिक्यूल्स, टुडेज टॉपिक एटम, लॉज ऑफ केमिकल कॉम्बिनेशन, मॉलिक्यूल आयंस, ये सब हम लोग पढ़ेंगे। टॉपिक आज हमारा टॉपिक पर एटम है। ओके, तो कॉन्सेप्ट्स टू बी कवर्ड में एटम, साइज ऑफ एटम, सिग्निफिकेंस ऑफ एटम। ओके, तो लास्ट क्लास का रिकैप हम लोग पढ़ते हैं। रिकैप क्या था? यही कि atoms are tiny particles called, all matter consists of tiny particles called atoms which participate in chemical reactions. तो आपके atoms fundamental unit of matter है। atoms are indivisible particles, hence they cannot be further divided. तो उनको और divide, but in reality you can actually do it during nuclear fission. When a neutron hits a uranium atom, it splits into barium and krypton sometimes. So sometimes this happens. Okay, atoms of a given element are identical in mass and chemical properties. This is also correct. हाँ, लास्ट क्लास में डाल्टन्स थ्योरी ऑफ एटम नहीं इतना अच्छे से हम लोग नहीं कवर कर पाए थे, तो इसको मैं करा लेता हूँ। हाँ, एक स्टूडेंट ने पूछा था वाई इज़ ग्रुप 18 कॉल्ड ज़ीरो ग्रुप, तो ही एक्चुअली गेव द करेक्ट आंसर ऑल्सो, सो आई चेकड अबाउट इट। तो आपका ग्रुप 18 एलिमेंट्स आपका ज़ीरो ग्रुप होता है। तो रीज़न बीइंग ग्रुप 18 में कौन होता है आपका होता है हीलियम, नियॉन, आर्गन, क्रिप्टॉन, जीनॉन। तो ये आपके ग्रुप 18 एलिमेंट्स हैं। तो ये आपके अनरिएक्टिव होते हैं, इसीलिए उनको नोबल गैसेस भी बोलते हैं। ओके, और इनका जो ग्रुप का नेम होता है ज़ीरो ग्रुप। रीज़न बीइंग या दे आर इनर्ट गैसेस, सो ज़ीरो ग्रुप विल हैव ज़ीरो वैलेंसी एक्चुअली। सो वैलेंसी एक कॉन्सेप्ट है जो हम लोग बाद में पढ़ेंगे। वैलेंसी इज़ द कंबाइनिंग कैपेसिटी ऑफ अ एलिमेंट। ओके, combining capacity, so how much it can combine. So it is a measure of how much you can combine, how much an element can combine. Okay, so since group 18 elements generally, xenon can be taken as an exception sometimes. Okay, xenon can be taken as an exception sometimes. तो ये group 18 elements they have a valency of 0. Okay, their valency is 0. So from this 0, this name comes zero group, and because it doesn't combine with anything generally, so that's why the valency of group 18 elements ये आपका 0 होता है। ठीक है, so we'll continue. Then I will teach you regarding your Dalton's theory of atom. Okay, yeah, Tarun, you're correct. So Dalton's theory of atom. So Dalton's theory of atom, he had a few postulates, points he gave. Okay, so first one, hello Tarun. So first one he gave was all matter is made up of tiny particles. All matter. So Dalton's theory of atom. Okay, he did not give a model of an atom. He gave a theory. Okay, he theorized. Model means like a real thing. He just theorized it. So he based in theories on the basis of like concepts that were known during his time. Okay, so during his time, two concepts were known. One is the, basically they are said to be laws of chemical combination. One is the law of conservation of mass. Okay, another thing he knew, it was known by that time, was law of constant proportions, law of constant or definite proportions. So both of them last class I had taught you. Okay, so based on that he gave his points. Okay, yeah, Dalton was the English teacher, so also scientist because he was researching, and so obviously you will be, आपको उन्हें as a scientist consider करना पड़ेगा। तो Dalton's theory क्या बोले उन्होंने कि all matter is made up of very tiny particles, which basically he gave the term atom. All matter is made of very tiny particles. Okay, basically he is referring to your atoms. So atoms word was given by Democritus, Greek philosopher. So he was just continuing on his concepts. Okay, Next he gave atoms are indivisible particle. So he gave atoms are indivisible particles. Okay, indivisible particles which cannot be created, which can't be created or destroyed in a chemical reaction. Okay, he gave this term. So basically he is following a law of conservation of mass. The basis is this law that you cannot create or destroy mass in a chemical reaction. So since you cannot create or destroy atoms, thus your mass is remaining conserved in a chemical reaction. Now we know we can actually do it. So if you take a uranium atom, okay, an isotope of uranium, okay, and if you strike a neutron to it, okay, it can actually split, okay, it can split to, so different, so nuclear fission can have different products, okay. In one of the products it will give you your barium and krypton, okay. So this nucleus, this atom will split itself into two new atoms, okay, and in that scenario आपका mass conserved नहीं रहता if you calculate the mass of the products to the mass of the reactants. Now this is a nuclear reaction, not a chemical reaction. So here you will find that mass of the products is little bit less than mass of the reactants. The mass difference is actually converted to energy, E equal to delta mc square. So this is your Einstein's formula. Delta m is the mass difference between your products and reactants, that small decrease that is converted to energy. This was formula is given by Einstein. So this is a famous formula. So we know in a nuclear reaction mass does not remain conserved and you can actually change your atoms. So you can create new atoms out of the old ones. Even in nuclear fusion, so your hydrogen fuses to form your helium atom. So you can actually create atoms also from old atoms in a nuclear reaction, but in a chemical reaction this always, the atoms remain same. Again, reason being, nuclear reactions you have extreme temperatures and pressures, so in those extreme conditions only these things start happening, okay. So you can have okay, so you can have a so if hydrogen is reacting with oxygen to give you water, okay, so your atoms don't change, unlike your hydrogen fusing to form helium. So here the atoms are changing, but in the case of a chemical reaction atoms are not changing, they are staying the same, again because conditions don't permit it to do so, okay. You need extreme temperatures and pressures for nuclear fusion to occur. You know, you require a big thing like a sun. Sun is a very giant object, extreme temperature and pressure, then only your hydrogen fuses to form helium. No, they are not wrong, they are they have their own domain, like they have their domain, like most 99.9% of the time they will be correct, it won't be incorrect, okay, because we don't deal with nuclear fusion or fission in our daily lives, we deal with chemical reactions. So chemical reactions, they don't have extreme temperatures and pressures generally, okay, thus you don't get your atoms changed to something new. Yeah, by nuclear fusion you actually do that, it is possible, like, but human beings, it requires a large amount of energy, okay. So let's say you are producing some gold, gold is a product, so it will have some economical value. Now let's say you use that incredible amount of energy to produce that gold. So if the cost of producing gold is greater than the gold that is produced, then it is an uneconomical venture. So that is why no one does it. For experiment or for science reasons, some scientists can do it, but in a general scale it is not done, okay. And gold is very difficult to produce, it is only found, it can't be even found by sun, even though it is so massive and has so much energy, you need a special set of circumstances like a supernova. Supernova is when a very large star, way larger than our sun, it explodes at the end of its lifespan. During that explosion gold is formed, so extreme to extreme situations can only form gold, okay. And that's why we don't do it, because it's uneconomical for us. It is much cheaper to find and mine for gold, and gold is very unreactive, so you can actually find unreacted gold nuggets basically. So very brief refining processes you can obtain gold, pure gold, okay. That is why gold is not produced Actually, I don't think it is also feasible for us to produce it in a macro scale. Very few atoms we might, but so many, like in a bulk scale, it is difficult. Okay, so I hope Tarun your doubt is cleared. Okay, so we will continue. Next we have, if you doubt is not clear, you can say in the chat. If it's clear, you can say, then I'll, like I can explain again. Okay. So next part is, so atoms are identical in, so similar atoms, they are identical in mass and properties. Similar atoms are identical in mass and properties. Okay, so similar atoms are identical in mass and properties. So what does this mean? Like if you have two hydrogen atoms, so two hydrogen atoms, they will have the same mass. Okay, they will have the same mass, and in a hydrogen atom you have one in the nucleus. I had explained what is a nucleus in the last class. So you have one proton in the nucleus. Okay, this is a nucleus. Surrounding it in the circular orbit based on Bohr model of atom, one electron is revolving around the hydrogen atom. Yeah, isotopes and isobars are correct, but for like during the time of Dalton, isotopes I don't think was discovered, because isotopes was found after you found, no, isotopes are not present, but their effect is present. So you will see the mass of hydrogen, it is not written 1. Okay, so it is written, so 1 in the terms of U yesterday, so U is a unit to measure the weight of atoms. Okay, so U is a unit to, so like gram and kilogram is a unit to measure you know, everyday things. So 1 kilo of your onion, 500 gram of onion. So atoms are very small. 1 U approximately, this weight is 1.6 into 10 to the power minus 27 kilograms. So it is a very small unit of weight. So that is why we always give weight of atoms, individual atoms or molecules in terms of U. Okay, but in reality it should be 1 U, but you will see in the periodic table it's written as 1.00, I think somewhere around 008, somewhere around 008, okay, U. Okay, I might be a bit wrong regarding this. Okay, so let's say it is little bit, so I'll just rub that because I am not sure regarding the exact decimal places. Okay, so let's say it is a value which is close to U, but so which is close to 1. So let's say the value is x, so it is very close to 1, but it is not 1. Okay, so why it is not exactly 1? Because hydrogen has 3 isotopes, protium, deuterium and tritium. So they take the average atomic mass. So average atomic mass, I think we will learn in this chapter later on. So they take the average of the 3 isotopes based on their how much they are found in nature. So I think protium is found like 90% plus in nature, deuterium is little bit less, tritium is almost not present. So using the 3 isotopes and their percentage of abundance in nature. So how much of hydrogen is your protium, how much of hydrogen is deuterium, how much is tritium, they take an average value, and that is why that value is not exactly 1 U, it is little bit greater than 1 U, because deuterium mass is 2 U, tritium mass is 3 U. So obviously if you take an average, its value will be little bit greater than protium's average. Okay, so your isotopes, they are not present in as a whole, but they have their effect. So that is why your atomic masses, you will see it will be given in your periodic table, their values are never integers, they are always decimal numbers. Reason being, they are averages of various isotopes that have been discovered by scientists. Okay, so I hope this doubt is clear for you. Okay, so Tarun, you can say in chat if your doubt is cleared, then I will move on to the next point that was given by Dalton in his theory of atom. So you can tell in chat if it's not clear, I'll explain again why isotopes are not present, and if, okay, so we'll continue. So fourth point you have is, he gave atoms combine in ratio of small whole numbers to form compounds. तो आपका atoms combine in ratio of small whole numbers to form compounds. Okay, so what do you mean by this? So this is basically based on your law of constant proportions. So if you have a molecule of CO2, so I explained last time. So if you have a molecule of CO2, so molecule of CO2 in terms of that U, unified mass, U is called unified mass, older name was atomic mass unit, AMU, now it is called unified mass U. So in terms of U, its weight is 44 U approximately. Okay, so 44 U. So in this, you will always find 12 U will be carbon. So weight of a atom of carbon is generally 12 U. You have isotopes of carbon, but if you take the generally found most abundant form of carbon atom, it will have a weight of 12 U. Your oxygen will have a weight of 32 U. Okay, so this is 12, this is 32. So the mass ratio, which is your law of constant proportion or definite proportion, it will always be 12:32. Okay, thus since the mass ratio is always 12:32, obviously they will be combining in simple whole numbers, because if you have 12 U of carbon, that means you have 1 atom of carbon. If you have 32 U of oxygen, that means you have 2 atoms of oxygen. So this is why they always combine in ratio of small whole numbers to form compounds. So this ratio, so in terms of atoms, the ratio between carbon and oxygen is 1:2. Okay, this is a result of this ratio. Okay, so this is why your atoms combine in ratio of small whole numbers to form compounds. इसीलिए आपके atoms simple whole numbers में आते हैं, because उनका mass ratio हमेशा constant रहता है based on आपका law of definite proportions. So I hope this part is clear for everyone. So you guys can tell in chat if it's clear. So I'll continue. Yeah, but I think carbon 12 is very abundant. So even if you take the average, it will come very close to 12. Okay, so see, like hydrogen has 3 isotopes, protium, deuterium and tritium. So average based on their abundance, if you take the average, it is coming very close to 1. So that is why we take, for ease of calculations, its atomic mass to be 1 U. Similarly for carbon, even though generally it has 3 isotopes, carbon 12, carbon 13, carbon 14, but carbon 12 is very abundant. So that is why the average will be very close to 12. So we take for an approximation 12. But in the case of chlorine, generally it has 2 isotopes. Chlorine, I'll teach that later on. So there is a simple formula. Okay, so I'll teach that, don't worry. Okay, so it's a very simple thing, it's just an average thing. Okay, so in case of chlorine, you have chlorine 35 and chlorine 37, but chlorine 37 is present in a bit more quantity relative to other isotopes for other elements. So that is why that average is 35.5. So you can't take 35 because it is a very big, 0.5 is a very big difference. Okay, so for hydrogen it is very small, like 1 point in very small decimal numbers, that's why. So average thing we'll learn later on. I think we learn regarding atomic mass and mass numbers later on in this chapter. So during that time I'll explain that. Okay, it's a very simple thing. You take basically it's like average only, but it's simple. So next, last point is relative number and kind of atoms are constant in a given compound. Again, a result of your law of constant proportions. Relative numbers and kinds of atoms are constant in a given compound. Kinds of atoms are constant in a given compound. Okay, relative numbers and kinds of atoms are constant in a given compound. Again, this thing, your numbers, this number ratio is always same for carbon and oxygen and carbon dioxide and kinds of atoms. So basically he is saying your atoms can't change when they form compounds. Okay, so that's why, again, because it's a chemical reaction, not a nuclear reaction, thus your atoms will always stay the same. So carbon dioxide will contain the same carbon which was used in as a reactant to form the carbon dioxide as a product. Okay, So this is again following your law of conservation of mass as well as law of constant or definite proportion. So Dalton basically gave a theory based on the previous theories which were recently proven. Okay, based on that he gave his theories. So I hope everything is clear. Okay, regarding Dalton's theory of atoms. So we'll start out today's topics. Okay, so आज का टॉपिक हम लोग देखते हैं. So I have to check regarding the same. Is it same or different? But nuclear reaction like it's type of a permanent change. Okay, so you will say both nuclear reaction and chemical reaction, they are irreversible. Okay, and nuclear reaction is more irreversible. Basically, to change back into that same atom which originally formed, which was originally used to form the new atoms, it is very difficult. Okay, so you can say both are irreversible. That would be the better answer, I think. So although I will check regarding the same if it is considered as a chemical reaction or not, but both are irreversible, that is sure. So how small the atoms are? So atoms are very tiny objects. Okay, we can't see atoms, like we all are made up of atoms, but we can't see them. We only see the bulk, how it looks in a bulk, like this pen. So this pen is made of plastic. Plastic means it must contain carbon, but I cannot see the carbon because it is so small, it is not visible to my naked eyes. Okay, even sophisticated instruments like your microscope, under a microscope you might see your bacteria, but you can't see the atoms which make up that bacteria. Or an electron microscope, even it can, you know, go even further in terms of seeing tiny objects, even that cannot see. Although we have seen the surface of atoms, like surface of silicon, I told that previously in a few classes back. Instrument is used, it's called scanning and tunneling microscope, STM. Okay, so you can use it to at least see the surface. So surface of silicon has been observed. In like how an atom actually looks, it's a bit bleak, it's not sure, but we have seen the surface anyway. Okay, now how small these atoms are, there is actually a formula. So I have explained you basics of Bohr's model of atom. Using that we have a formula for radius of atom. Like we have seen the surface, so now will you qualify it as seeing the atoms? It's up, like we have to check actually. So will you say we have seen atoms, or just you will say surface? So we have to check, but we have seen the surface. So if you have a silicon piece, we have seen the surface of that silicon piece using that STM. Okay, so exactly how it looks we have to check. Okay, so now how small these atoms are. So there is a formula for radius of an atom. So आपका radius of atom Rn. So I had told you like hydrogen atom. Okay, hydrogen atom has one proton in its nucleus. Surrounding it in a fixed orbit, one electron is revolving. Okay, so this fixed orbit, first orbit. So first orbit. So these orbits are also named as shells. Okay, so for first shell, this n means the shell number. Chiral center we'll learn in next chapter, Tarun. Okay, it's related to mirror images. Okay, chiral actually, so it's related to mirror images. We'll learn it in the next class, next chapter. Okay. It's related to are mirror images superimposable or not. So like this is my left hand. Okay, so its mirror image, is it superimposable on it or not? So that is the question. So do they fit perfectly? So this pen's mirror image should fit on it perfectly. Okay, so they can be, they are the same, but for certain cases the mirror images are not same. Okay, so that is why they don't fit, they are not superimposable. So chirality is related to that. Okay, sorry, structure of atom. Okay, it's okay, so it's taught in 10th standard. I'm sorry for that. So carbon and its compounds chapter you will learn. So okay, chirality I'll just explain then in the next class. Okay, so next YouTube class is on I think next Wednesday at 2 p.m. So I'll explain what is chirality. So if you can attend the class, if you can't, you can see in the recording. Okay. Okay, anyway, so for a first orbit, n value will be equal to 1. N is basically the orbit number. First orbit, n is 1. So radius of atom, of a hydrogen atom. Okay, so the formula is 52.9 n square by z. So where n is this orbit number, okay, this orbit number, and z is the atomic number. Today night, okay, I will explain. If you want, I will explain what is chirality and what is chiral center, no problem. Okay, now z is your atomic number. Okay, z is your atomic number. For hydrogen, the atomic number is 1. So z is a symbol for atomic number. Atomic number is the number of protons in the nucleus of atom, which is experimentally proven. So atomic number of hydrogen is 1. Okay. So for hydrogen, the radius of atom will be, so z is equal to 1. So z will just go away. So you can write 52.9 n square. Okay. So for n equal to 1, so radius of atom is basically this distance, center of nucleus to your this shell, outermost shell in the case of hydrogen. So this distance is your radius of atom, which gives you a size of the atom, gives you an idea about size of the atom. So 52.9 n square picometer, this value is in picometer. 1 picometer is equal to 10 to the power minus 12 meters. Okay. So this value will be for first orbit of hydrogen. So you will learn in higher grades, I think in the next chapter also it is there. So Z, I think they use like there are certain experiments, okay, there are certain instruments by which you can check the masses, okay, various ways to check masses. So that much I can tell for you now. Name of that instrument I have to check a bit, okay. So I will check and tell you. Okay, there are certain instruments by which you can find the exact weight of the atom. Okay. So Z is equal to 1. So in this case, atomic number. So basically, you can find number of protons. Okay, there are certain ways to find it. Okay. So 52.9 n square picometer. So for the first orbit, this will be called a ground state. Ground state means unexcited state. So if a electron gains energy, so electrons can gain, if you provide the electron energy, it can jump to higher orbits. So n can be equal to 2, n can equal to 3. So n is still infinity. Infinity is the like it can go on till infinity. Okay. But for the first orbit, you will tell it to be a ground state. That means unexcited state. So unexcited hydrogen atom, the size will be 52.9 n square picometer. So n is equal to 1, n square will be also equal to 1. So it is 52.9 picometer. So which value will be equal to 52.9 into 10 to the power minus 12 meters. You can change it to nanometers also. So it will be 0.0529 into 10 to the power minus 9 meters, which is equal to 0.0529 nanometers. So this is the size of the atom, like just for the sake of visualizing. No, n can go till infinity, z can't go till infinity. Z you can't take it till infinity. There are certain cases, as the atomic number and atomic mass increases, so atoms tend to become less stable, okay, after a certain point. That is why Z equal to 92 or uranium is the heaviest element that you find naturally. You cannot find any element heavier than uranium in nature anywhere in the universe. Okay, it is actually proven. So for any element greater than atomic number 92, it has to be synthesized in a lab, okay, using certain methods. So again, those elements are generally unstable. They will undergo nuclear fission. So they will undergo fission reaction by, like, they are unstable. So they will split into other atoms, or they will give off radioactive, they will show radioactivity. So will give off the alpha rays, gamma rays, beta rays to reduce their atomic number and their mass number, okay, to gain more stability, to reach a point below Z equal to 92. They will try to do that because Z greater than 92 is not naturally stable. We can get certain atoms, but we have to synthesize it. We can't find it in nature. Okay, so this is the size of the atom. So it is 0.0529 nanometer. Now again, this is based on Bohr model of atom. Okay, and this formula It is accurate for your hydrogen or hydrogen like species. What do I mean by hydrogen like species? Like He plus. Okay, if you take He plus, so helium in its nucleus, it has 2 protons and 2 neutrons, and revolving around that nucleus you have 2 electrons. Okay, 2 electrons. Okay, so if you remove one electron, electrons can be removed by providing energy. Okay, if you remove one electron, you will have He plus. What is He plus? It is a hydrogen like species. Why not He itself? Because it is not a hydrogen. Actually, Bohr's model of atom is accurate for species which has one nucleus and one electron. Okay, so it is more accurate for those. So his theory is more applicable to those species. Now n is equal to 1, but Z, you want only one electron. So n is equal to 1. There is a formula how many electrons an orbit can have. So there is a formula. The max number of electrons formula is equal to 2n square, where n is the orbit number. So for first orbit maximum you can have, good afternoon Himesh. So for first orbit maximum you can have 2 electrons, n is equal to 1, 2n square will be equal to 2 into 1 square, which is equal to 2. So 2 electrons are the max. But the formula that Bohr gave for radius of atom, it is more accurate when you just have one electron and one nucleus. Okay, so that is why. Basically he see electrons. So if you have 2 electrons, okay, so both electrons are negatively charged, they will have repulsions. So while calculating his formula and forming his model of atom, he did not take into account these inter-electronic repulsions. That is why his formula becomes less and less accurate as the number of electrons keep on increasing. So multi-electron atoms like gold, platinum, so it is not very accurate for them. So because he did not consider this repulsion between these electrons. Okay, so that's why if you have one electron you cannot have these repulsions, and that is why this formula starts becoming more accurate. Okay, so that is the reason. That's why you take He plus, Li2 plus, even lithium 2 plus. Lithium atomic number is 3. So if you remove, so it will have 3 protons, thus it will have 3 electrons. If you remove 2 electrons, it will have a plus 2 positive charge. Then it will have also 1 electron. Then also this formula is very accurate for them. Okay. So हिमेश आपको भी समझ आ गया तो आप बोल सकते हो. तो रेडियस ऑफ एटम, साइज ऑफ एटम, ठीक है. तो इसके लिए ओके ओके हिमेश, सो विल कंटिन्यू. हाँ, nucleus also there is a formula. Okay, okay, for nucleus, radius of nucleus. Okay, so nucleus is very small compared to your so radius of nucleus. Okay, the formula is r naught a to the power 1 by 3. So cube root of a, where a is the mass number. Okay, a is your mass number. So if I don't have any electron in K shell and one on L shell, can I use this formula? So we have to check. Okay, because we have to check. I have to also check. So you read. Okay, ये जो formula है आप लोग 11th में पढ़ते हो, अभी नहीं पढ़ते हो, तो उसके हिसाब से okay, so we have to check, is this formula valid for see, you can find. Okay, so let's say, so in terms of orbit you can find. I am not sure if the electron is present. So let's say you want to find the radius of third orbit for your He plus species. Okay, you can use this formula. So will that electron be, so you can find the radius. Now question is that electron present in that third orbit? So we have to check. I have to actually check. So how it is given in terms of Bohr, like you will learn in 11th grade, it talks about like orbit radius. It does not talk if an electron is present in that orbit, but I guess it should, if that electron, let's assume it is present, then it has to it will be present at that much distance. Yeah, that I have to check. that second point which you are giving, that is that possible, no electron in K shell and L shell, yeah, that is possible. So if you take hydrogen atom, if you provide that electron certain energy, it can jump to the second shell. Okay, that is the basis of Bohr model of atom, that is possible. So I guess so that part I have to check a bit. Okay, does that presence of electron affect it, not affect it, but you can actually make it jump, so I have to check it. Okay, second point is true, you can do it. So by just providing certain energy, so there is some definite energy gap between the first shell and second shell. If you provide that definite energy gap, that electron can jump into the second shell. So you won't have any electron for an hydrogen in the first orbit, you will have one electron in the second orbit, but it will be at an excited state. So you will tell that electron has gained some energy and uska abhi excited state hai. Ab first point and second point I have to check. Okay, like even if an electron is present, you can still use this formula. Okay, so you can actually calculate the radius of orbit. So it's just, is the electron present or not, that is not we have to check. Actually the formula you've given, it's in EV, right? So energy formula is minus 2.18 13.6 yeah, divided by n square, correct? I think it is minus 13.6 by n square for hydrogen energy formula which you are giving in electron volt. Okay, 1 electron volt is 1.6 into 10 to the power minus 19 joule. Okay, so it is minus 13.6, I don't think it is minus 13.4. No, that electron, so see again theoretically speaking, आपका electron वो orbit में हो सकता है. So see, this formula gives you radius of that orbit. Okay, radius of that orbit. Okay, so okay, so I think so I'll check a bit. Okay, and then I'll say that would be the better reason. Okay, so second orbit you can calculate the radius. This formula is giving you the value of the radius. Using that energy value, you can calculate how much energy, that minus 13.6 by n square electron volt in terms of energy. So if you're providing that much energy, that is the energy of the first orbit. Okay, now using that same formula, so if you take E2 second orbit's energy, it will be minus 13.6 by 2 square EV electron volt. So it will be minus 13.6 by 4 EV, so it will be equal to 3.4 EV. Okay, so if you provide the electron energy of so it will be minus 3.4 minus of minus 13.6, for first orbit energy is minus 13.6, so you will get an answer of I think 9.8, sorry 10.2. So if you provide an energy of 10.2 electron volt, okay, 1 electron volt is 1.6 in 10 to the power minus 19 joules. So if you provide energy, electron volt is a unit of energy like joules. Okay, so if you provide this much 10.2 electron volt of energy to that electron revolving around the hydrogen nucleus in the first orbit, it will jump to the second orbit. Okay, then you can also calculate the radius of the electron orbit using the formula of 52.9 n square. Okay, so I think Tarun, you are correct. Okay, so electron will be present because you are calculating the energy and the radius, so it has to fall. No, energy. So Tarun, obviously Schrodinger's equation, Schrodinger's model of atom आपका ज़्यादा accurate होता है. Okay, Schrodinger's model of atom आपका more जो कि quantum mechanical. So Schrodinger did not give a model of atom. Loads of scientists using their contributions, they formed a quantum mechanical model of atom. Obviously it is more relevant and more accurate than your Bohr model of atom. But you guys, आप 9th standard में हो तो आप लोग को Bohr model of atom के साथ ही चलना है, क्योंकि you don't read quantum mechanical model of atom, you read Bohr model of atom, and you also don't read these energy formulas or these radius formulas. I just told to give you an idea about the size of an atom. Okay, so थोड़ा आप visualize कर पाओ, like every time. Obviously Schrodinger's equations are more accurate because that is which confirms to your experiments more, not the Bohr model. But again आपके course में Bohr model है, so you will have to follow it. एंड बोर मॉडल इज़ अ गुड अप्रोक्सीमेशन फॉर वन इलेक्ट्रॉन सिस्टम्स. वन इलेक्ट्रॉन मतलब आपका अगर एक इलेक्ट्रॉन है एक न्यूक्लियस है तो उसमें बोर मॉडल ऑफ एटम एक्यूरेट होता है थोड़ा, ठीक है. बट ऑब्वियसली मोर एक्यूरेसी will come from your Schrodinger's equations. Not Schrodinger's equations, quantum mechanical model of atom. Schrodinger did not give a model of atom, he just gave some equations based on which many scientists over many decades they formed the quantum mechanical of atom. Not one scientist is given the credit, loads of scientists they helped in making it. Okay, like Bohr model of atom, even though Bohr hypothesized, he used Rutherford's model of atom, he used various other principles to get to his model of atom. He used Planck's formula to get. So scientists generally take help from the scientists who come before them to theorize something. So I hope Tarun aapka clear hai, and Himesh, if you are not able to understand few things you can also ask. So Tarun, your Schrodinger's equations will be more accurate every time because obviously. Okay Himesh. तो यहाँ पे ये जो आप देख रहे हो ये आपका एनर्जी का फॉर्मूला है ई एन, एनर्जी ऑफ एन इलेक्ट्रॉन. ये आप एक्चुअली 11 में पढ़ोगे. इसका वैल्यू होता है ई एन इक्वल टू -13.6 जेड स्क्वायर बाई एन स्क्वायर इलेक्ट्रॉन वोल्ट. इलेक्ट्रॉन वोल्ट इज यूनिट ऑफ एनर्जी. ओके, ओके तरुण, दैट पार्ट आई हैव टू नो सी आपका जो स्क्रॉडिंगर्स इक्वेशन होता है इट यूजेस different like it uses calculus, so and some another concept in calculus it is called partial derivatives. So partial derivatives you will only study if you do graduation in science. So if you study either engineering or you study physics or you study maths or you study chemistry, then only you will be taught those equations. So anyway I will check if L is the length of space, L is the radius of atom, I will check. Certain aspects even I might not be knowing, I will just be honest, because the level of math till which I have learnt may or may not be enough to understand his equation. Okay, so to understand his equation you need a understanding of partial derivatives. So partial derivatives is a higher form of calculus. So in 11th and 12th आप लोग calculus पढ़ोगे, उसका भी एक higher form होता है partial derivatives, PDEs, partial derivative equations. तो उसका भी हम लोग, सो आई डिड इंजीनियरिंग, तो हमारी इंजीनियरिंग में उसका कुछ पार्ट ही पढ़ाया जाता है PDEs का, विच इज़ रिक्वायर्ड फॉर अस. सो लाइक वॉट एवर इज रिक्वायर्ड इज टॉट टू अस, बट प्योर साइंस, yeah, but it is because it's complicated. PDEs are very difficult to solve. Certain it's not easy. So because that is why we use softwares or आप computers use करते हो to find. So let's say you have a bridge. Okay, before people used to calculate everything for a bridge, how much force, how much length, but it is not easy. So that is why we use now softwares. So they do the calculations. You just need to put in the values and your design. You should have a basic understanding of the design, like good understanding, but the calculations can be done using softwares because it's not easy to solve those equations. Okay, you will have another thing for these bridges and stuff. We have another branch of engineering, it's called finite element analysis. So in finite element analysis we use another branch of mathematics, it's called matrices and determinants. Okay, so even that is very complicated. So as you study more, so अभी आप डरो मत, 9th-10th में जो आप मैथ पढ़ोगे, 11th-12th में और थोड़ा पढ़ोगे, उसके आगे अगर आप लोग मैथ और साइंस में और आगे पढ़ोगे तो और भी कॉम्प्लेक्स मैथमेटिक्स पढ़ोगे, which is not easy, but obviously it makes you smarter, and because when you do something hard it makes you better if you are able to do it through practice or through repeated trials. Okay, so that's why. नाउ अगेन हिमेश, ये आपका फॉर्मूला होता है, एनर्जी का फॉर्मूला होता है फॉर एन इलेक्ट्रॉन रिवॉल्विंग अराउंड द न्यूक्लियस. तो ये Z आपका एटॉमिक नंबर होता है. ओके, एंड आपका n आपका ऑर्बिट नंबर होता है. ओके, सो तरुण, आई थिंक यू आर करेक्ट. वो इलेक्ट्रॉन, दैट इलेक्ट्रॉन, yeah, you can learn, but for learning calculus you also need to learn more algebra. Okay, that is also a thing. So because everything is interrelated, so first you have to actually learn algebra, then you have to learn 2D and 3D, then only you will understand calculus. So that is why in 11th standard we learn in that order. We are first taught algebra, then we are taught some 2D and 3D geometry, coordinate, like coordinate system, XYZ axis. So there is a branch of mathematics dedicated to that. Then we are taught your calculus, because these two are required to understand calculus. Okay, so when you will open that calculus book, it will look very weird because these fundamentals you have not learned. So like in 9th and 10th standard, I think you will learn regarding finding the root of a quadratic equation. So plus minus b plus minus root over of b square minus 4ac divided by 2a. So that formula. Okay, now I might be a bit wrong regarding that formula also, I'm a bit rusty, but I think that is correct. The formula of roots of quadratic equation, I think it is minus b plus minus b square minus 4ac root over divided by 2a, if I am not wrong. I might be wrong, so you can correct me if I am wrong. The root of a quadratic equation. Okay, so similarly you will have cube roots. Okay, that's good. Time कितना हुआ? Okay guys, so जस्ट रिमेंबर, आपका सारा मैथ और साइंस सिक्वेंशियली आपको पढ़ाया जाता है, क्योंकि जो चीज़ें बाद में पढ़ाया जाता है उसको समझने के लिए आपको प्रीवियस चीज़ों को समझना पड़ता है. दैट इज़ द रीज़न. द ऑर्डर इज़ इन दैट मैनर. ओके, अगेन दैट इज़ बिकॉज, ओके विल कंटिन्यू. सो ये आपका एनर्जी हुआ, ये आपका रेडियस का इक्वेशन हुआ, ठीक है. और न्यूक्लियस का भी एक रेडियस का इक्वेशन होता है, आर नॉट ए टू द पावर 1/3. इसमें आर नॉट का वैल्यू होता है आर नॉट का वैल्यू होता है 1.2 इंटू 10 टू पावर माइनस 15 मीटर्स. 1.2 इंटू 10 टू पावर माइनस 15 मीटर्स. और ए होता है आपका मास नंबर. मास नंबर कुछ नहीं होता, आपका सम ऑफ प्रोटॉन्स एंड न्यूट्रॉन्स होता है. सम ऑफ प्रोटॉन्स एंड न्यूट्रॉन्स को हम लोग मास नंबर बोलते हैं. ओके, फॉर हाइड्रोजन मास नंबर इज़ 1 का क्यूब रूट आपको फाइंड करना है, फिर आर नॉट मल्टीप्लाई करना है. सो आपका आंसर इस ऑर्डर में आएगा, 10 टू पावर माइनस 15 मीटर्स. ओके, आपका फर्स्ट ऑर्बिट का रेडियस, सो ये आपका कितना है? सो लेट्स टेक इन दिस मैनर. सो इट विल इक्वल टू 5.29 इन 10 टू पावर माइनस 10 मीटर्स. ओके, द रेडियस ऑफ द फर्स्ट ऑर्बिट ऑफ हाइड्रोजन एटम. रेडियस ऑफ द न्यूक्लियस ऑफ हाइड्रोजन एटम आपका ये ऑर्डर में आ रहा है, 10 टू पावर माइनस 15. सो यू कैन से योर एटम इज 10 टू पावर 5 टाइम्स लार्जर. कैसे कि अगर 10 टू पावर माइनस, तो इसका ऑर्डर किस में आ रहा है? आपका रेडियस, एटॉमिक रेडियस का ऑर्डर 10 टू पावर माइनस 10 में आ रहा है. एटॉमिक न्यूक्लियस का ऑर्डर 10 टू पावर माइनस 15 के हिसाब से आ रहा है. तो इसको अगर आप डिवाइड करोगे आपका आंसर आएगा 10 टू पावर 5. तो यू कैन से योर एटम इज 10 टू पावर 5 टाइम्स लार्जर देन योर एटॉमिक न्यूक्लियस. सो मोस्ट ऑफ द स्पेस इन एन एटम इज एक्चुअली एम्प्टी. Okay, most of the space in an atom is actually empty based on Bohr model of atom. Okay, so most of the space in an atom is empty. So we are all made of atoms, but most of it is actually empty space. Okay, so I hope this is clear to everyone. The atomic radius, the nucleus radius, and your ratio between the size of the atom to its nucleus. Okay, तो हिमेश और तरुण आप बोल सकते हो अगर आपको समझ आया नहीं है. सो इफ़ यू डोंट, आई विल एक्सप्लेन अगेन. ओके, तो बेसिकली ये जो रेडियस सेंटर ऑफ न्यूक्लियस से टिल द आउटर एज ऑफ द न्यूक्लियस, ये रेडियस बिग न्यूक्लियस का रेडियस है. और सेंटर ऑफ न्यूक्लियस से लेके आपका फर्स्ट ऑर्बिट, आउटर मोस्ट ऑर्बिट, ये आपका एटम का रेडियस है. ओके ओके गाइज, सो हिमेश आप भी बोल सकते हो. आई थिंक यू आर ऑल्सो इन द क्लास. सो अगर आप हो, यू कैन ऑल्सो से इफ़ यू अंडरस्टूड दिस पार्ट. इफ़ यू नॉट, आई कैन एक्सप्लेन अगेन. सो प्लीज़ रेस्पॉन्ड. ओके, सो हिमेश अगर आप क्लास में हो आप बोल सकते हो. नाउ आई हैव टॉट लोड्स ऑफ कॉन्सेप्ट्स हियर, तो अगर कोई भी चीज़ आपको समझ में नहीं आ रहा है वो भी आप बोल सकते हो. ओके सो हिमेश यू कैन रेस्पॉन्ड इन चैट अगर आपको समझ में आ रहा है नहीं आ रहा है. सो बेस्ड ऑन दैट वी विल सी. Okay, I will continue anyways. Okay, so next part is your so atom is million times smaller than your thickest human hair. Our human hair is of the order of few millimeters, I think. 10 to the power minus 3 meters. Millimeter is 10 to the power minus 3 meter or 10 to the power minus 4 meter. So your atoms radius of hydrogen atom. Okay, radius of hydrogen atom is how much? 52.9 first orbit. 52.9 picometer, which is equal to 0.0529 into 10 to the power minus 9 meters. So you can see the order. So 10 to the power minus 3 divided by 10 to the power minus 9. This will give you a ratio between the approximate size of human hair and approximate size of an atom of hydrogen, first orbit of hydrogen. So you will see this value is equal to 10 to the power 6. So I hope you guys know how to solve exponentials. So ये वाला part आपको I think समझ में आ रहा होगा. 10 to the power minus 3 divided by 10 to the power minus 9 is what? So if division is there, subtraction of power happens. Minus of minus 9 is equal to 10 to the power 6. Minus of minus will become plus. So I hope this part is clear to everyone, how I am dividing exponentials. I think this is taught to you in maths. Okay, that's good. So this ratio is your 10 to the power 6. So your human hair is a million times larger than your atom. Okay, like the smallest atom, hydrogen. Okay, not smallest, like the simplest atom, that would be the better answer. The simplest atom, which is your hydrogen. So we'll continue. Next slide we have size of atom is about 10 to the power minus 10 meter, 0.1 nanometer. So again it is taking your hydrogen atom as an example. I just showed you this first orbit of hydrogen in which this electron is revolving around. The radius is your Rn, R1 for hydrogen. It was how much? R1 for H is equal to 0.0529 into 10 to the power minus 9 meters. So which is closer to this value, 0.1 nanometers. Okay, approximately 0.1 nanometers. So we'll continue. So the radius of the hydrogen atom is about, again that value is coming again, 0.0529 into 10 to the power minus 9 meters. So approximately 0.053 nanometers. 1 picometer is equal to 10 to the power minus 12 meter. Why this is given? Because of that formula, 52.9 n square by z picometers. So 1 picometer is 10 to the power minus 12 meters. So we'll continue. So this question, easy question, the size of the atom is about dash. So you have three options A, B, C. So you can't interact with the question, but you can type in the chat. So is it option A, option B or option C? So I'll just drag the option and submit. So guys, whoever is attending the class, please answer in the chat which one you think is correct. Is it A, B or C option? Okay. Yeah, Tarun, it's correct. Your option is C. 0.1 nanometer is the closest value to 0.0529 into 10 to the power minus 9 meters. Okay. So this is my correct answer. Okay. So I'll be ending the class here. Okay. So we'll learn next class regarding your naming of atoms from where it's coming. Okay. So guys, thank you for attending this class. We'll meet again on YouTube on next Wednesday at 2 p.m. So thank you for attending the class.
Keep imbibing. We believe in you.